Okay, so I made a project recently. I reverse engineered a cheese grater, or a cheese shredder, whatever you want to call it. And it was part of a term project we had to do for a modeling course, and I just wanted to document this here as well on YouTube and make a video about it. So this is pretty much what it looks like. This wasn't where I got it from. I got it from like a local store, but it's exactly the product I used. It's the Hamilton cheese shredder. So to reverse engineer this, we pretty much have to buy something that looks like this, or buy this in my case, and we have to take it apart, take all the components apart. So in total, there are about 7 components. There's the handle, there's the grater inside, there's the body, there's the I call this the handle, and I think I called this the cheese holder or something. So there's the handle here, there's the wheel of the handle, there's some screws here or like a pin, and there's one more pin somewhere here, like a dowel here. So I pretty much had to take all those apart. I had to dimension all of them, and I had to figure out the best way to actually model them, because remember it had to be reverse engineered. So that was what I was working on. In total, it took me about 3 weeks to do. Bear in mind, I still had a lot of things going on by the side. So I think if I was doing just this, I should have finished all like within 2 weeks maximum, I'd say. So this is the what the final product looks like. Let me try and get the final product. Okay, yeah, perfect. This is what the final product looks like. This is the exploded assembly. Um, and yeah, these are all the parts I mentioned. This is the cheese holder. I had to put this down, because if I put this up, then it would interfere with these other parts. The cheese grater, the body, the cap of the grater, the handle, the um, axle, as well as the dowel. So each of these pretty much has to be modeled, and I have to come up with some nice ways of doing all of them. I'll show you guys the parts one by one in a couple of seconds, and then you see how detailed they were. Because I really wanted it to be as detailed as it should look, right? And in fact, like just looking at this side by side, just looking at the individual parts, it does look alike. It does look alike. I think it looks very much alike. So I'll say I did a pretty good job there. Like in terms of preserving the design intent, I think that was good. And in terms of preserving the like overall shape, I think that was also excellent. So yeah, I think I did a pretty good job, I'd say. So now let me show you guys the parts. I recall there are 6 or 8 parts actually. So let me try and pull those up and show you guys those parts. Okay, now I have to figure out where they are here on okay, should be here. Perfect. Okay, so these are the parts. Okay, so there are drawings for each of them. Just part of the project I did, but yeah, okay. So let me just show you guys. This was a handle, right? This was what made up the handle. So, I'm a very organized person, right? I don't know how to be not organized, even if it's just for a little bit. So, many of these, like this, the way I did the folder top to bottom, it's pretty much just because I wanted to be extra organized. It really didn't have to be that way. So this is the assembly of the handle, but the parts that make up the assembly, these are the parts. So this is the dowel, right? I think this was probably one of the easiest to do. Really didn't have much features. I just did a basic revolve to get this. Okay, yeah, I did a basic revolve for the entire piece actually. And then I did a cut extrude. I just, got extrude this. Now, in this, one thing I've learned in modeling from watching lots of videos and training and tutorials is that there are a lot of different ways to do one thing. So you might not agree with my way. You might think of something better, to, like, of a better way to do something, or even faster. Sometimes it might be faster than mine. Sometimes it might be slower than mine. Sometimes it might be more efficient. Like there are just a couple of different ways. And really, if you're someone that is just starting, I would say start by doing what makes the most sense to you. And then as you probably improve in your skills, you learn easier ways to do it. So um yeah, this is it. If you I mean it does look good. And then the context show, I think I pretty much just had to do because I made this at the origin, right? So that was easy to just use the intersecting plane and then just do like a cortex through all. Now, if you didn't do that, something I could have done would have been I could have created a tangent plane somewhere here, created a tangent plane, and then just also um, drew a sketch on the plane and then also cut it through. So that, of course, that would be longer, right? But it's still another way to do it, and that's the dowel. Now the handle of the dowel. If you look at the dimensions, many of the parts are very very small. This is 1/16, so yeah, 16th of an inch. That's pretty small. For some of the parts, I had to deal with a point zero 0.01 dimensions, point zero 0.02 dimensions. And let me show you guys the next one. This is the handle. Now the handle, it really wasn't so hard to do. It was just, took a little bit more time on it. Um, it was just a pretty much this looks like a slot. I had to do some tangent lines and tangent circles and all of that. This is also pretty easy, pretty understandable. I This was to, like, if you are turning the handle, you could also use this to turn it instead of using the actual handle. That's what this boss base is for. And then this hexagon, was this a hexagon? No, this is about six parts. No, four parts, octagon. Four, I mean eight, yeah, eight sides, octagon. So yeah, um, I really don't know what this is for. It doesn't seem like it had any use. But I mean, it was in the original design, so I had that there. And then why this one took a little bit more time was I had to basically um go under to the bottom plane and then try to also model it from there. So this goes on the greater cap, right? Because it's like a screw. So I had to actually model where the bus base on the greater cap would go through. That's what you see here, and then this one as well, and then this is pretty much what actually makes it move as a gear, and it engages something in the greater itself, and then it moves together. And lastly, for the handle assembly, I had to do the wheel axle. Pretty standard. That's where the dowel goes into. You see this hole here, it goes into it. And then why I said you had to be consistent in your dimensioning was that the dowel going through here, it has to go through here and it has to go through the handle. So if I wasn't consistent, the dowel would be too long, or the dowel would be too short, or the dowel would be too wide, and then it wouldn't make sense. So I had to do it that way. And then let me show you the handle assembly. Yeah, perfect. So it moves this way. The only reason why this doesn't spin is that I fixed this. The handle itself is fixed, so it wouldn't spin. But then the wheel axle should spin around the handle. That's pretty. It really doesn't do anything in the actual motion. Well, I'm guessing that's just like if you're actually holding a piece, they wouldn't want it to be rigid. So, anyways, just wanted to, like I said, make sure it has the overall design intent as the initial product. And that's all for the handle assembly. And the other parts here, let me pull up some of them. The grater itself was the hardest to think about. Um, and the only reason is what's happening at the bottom. This was the hardest to do. This was the hardest to do because the greater bottom had I'll call it some prongs, and the prongs was what made it hook in place, right? When you actually fix it in. If not, it's just slide in and slide out. So it's actually hooked in place and it hooked into this greater cap, which I'll show you guys in just a minute. So this was pretty much the hardest thing to do because it took me a while for some reason to actually like visualize it and understand what I needed to do. But eventually how I made this work actually was so I just did a regular boss extrude from tangents to not tangents. So you see the face of the grater. I pretty much had to I think it was just like an offset or like an extrude but with an offset from a distance. So that was the first thing that I did. And of course, I did it for just one place and there's this a circular pattern, which is what you see. So I pretty much had to extrude this just a little bit, the exact same way, or like profile of the actual greater cap. And then I'm saying that because it has a circular profile, so the inside is also circular. So I had to do it that exact same way. And then what I did next was I did a sweep. So after doing this, I called this like the base of the prong, right? So after doing this, yeah, I had to do a sweep. I had to draw like an entity that was just a let me show you. Yep. Kind of looks like it's spline, right? Kind of looks like a spline. So after doing that, and I also had to because it was a sweep I was using. But then something I noticed with this project is the manner in which you sweep a profile matters, or you sweep through a profile matters. So you could actually sketch what your actual profile is for the sweep, but the entity being swept matters a lot. How you connect it to the profile, and I don't think I'm making a lot of sense, but if you look at this two, for instance, so I had to connect the middle of my sweeping profile to uh, the path, right? But then what I'm explaining to you is if this was at the middle of the rectangle itself, right? And I actually had the slope, it would look different than it does look now. So what I had to do was whenever there was like an intersecting body, I had to sweep from that body, not from the outside. Because if I had swept from the outside, there would have been a little bit of a hole down there. I don't know. Maybe I didn't. Maybe I wasn't doing it right initially, but I found that problem. So whenever I was sweeping, and even till now, anytime I'm sweeping again, I try to make sure I'm sweeping from somewhere where it intersects or where it's closer, just so that when you actually make that sweeping profile, it connects to the body, right? If not, SolidWorks is going to view it as a new body since it really doesn't connect. And sometimes they also throw you an error saying the body doesn't have an intersecting profile, something like that. So that was pretty much the hardest thing to do in this part. And then the holes weren't so hard. I had to make them ellipses because they weren't perfect holes. I had to make them slants. I had to make them slants, you know, because the holes also weren't straight. And then after making a slanted line, I basically had to do a linear pattern. But it was nice because that's my first time realizing that you could actually do linear pattern but with a path. So I, I always thought linear pattern was literally just X and Y. But I was able to find out that you could do linear pattern with a path. Let me see if I can show you. Yeah, so I pretty much did that and I just like linear pattern it. Or then what something you could also do is after like making the linear pattern. SolidWorks usually for linear patterns, especially if you're in sketch, it doesn't anchor the origin of the pattern to somewhere. So after doing this, you could just tell SolidWorks like maybe use an angle or something, or like dimension, and dimension the first entity to the second one, bend it how you want, or turn it how you want, and then SolidWorks pretty much understands you want the same pattern to be done for all of them, and it just follows that path, and then you can anchor the origin. So, um, and then what else? Yeah, I think that's pretty much it. I didn't create a lot of planes and something like that here. I just had to do one plane here, yeah, for the sweeping profile, and yeah, that's it. That's for the grater. Now the next thing is the greater cap. I also wouldn't say this took me a while to do. It was also one of the things that I had to like had to work on the top plane, and I also had to work on the bottom plane. So this was the hardest to do when I was working on the assembly, and that's because there are a lot of things going on here. I know it doesn't seem that way, right? There's a hole here for which the this is the hole I was talking about, um that was the grater would go into. No, I mean this in the handle. Now, yeah, this handle, if you remember, there was like a boss base at the bottom, and that goes actually goes into here. Now there are a lot of things going on here because remember the boss base I also talked about. It goes in through this hole, and the outer portion as well. It basically should cover the bottom of the hand. So there are a lot of things going on here, and the holes as well. The the holes is where the prongs of the grate are going to. So that was really difficult for me to actually get my mind across because I really had to make a lot of changes to the dimension to make sure, like, it actually made sense and everything worked the way they were supposed to work. Because remember, it's a really small item, so there are a lot of inaccuracies with the like initial, dimensioning and measuring and all of that. So yeah, but eventually it worked well because, like I said, you'd see the assembly in just a bit. Everything looks so intricate. So that's it for the greater cap. The next one is the greater body. The greater body, oh my God, this took me a while. This took me about 2 days. The only reason is that there were a lot of sweep profiles I had to create on this. Just yeah, there are two profiles here. Yeah, because it was this took me a while. That's all I'm gonna say. This took me a while to do. But yeah, I used a lot of tips here. I used reference planes for these for the whole. I use sweep that I just talked about. I use extrude with offsets. There's some fillets here. I used the mirror features as well, so I had to model it on one side and then just um, mirror it to the other plane. And yes, this remember when I was talking about sweeping? This is also this is another example where you really have to be careful of how you sweep. And I think this will probably allow me to explain it better. If you look at this sweep I did here, right? Let me try and actually, you know, just hide the rest of them. So if you look at how this had to be swept, had to basically sweep this from inside, and you see how the sweeping profile is slant, so that if not, if the sweeping profile was straight, what would happen is that when you're actually sweeping it, especially since since your part is an angle, um, the upper part would actually intersect with the body, but the bottom part would not. Same thing with here. It's a circle. This is a circle. So I had to make sure when I was sweeping, I actually went inside the circular feature. If not, it's just gonna look like a tangent. So that the middle part will probably intersect, but the upper part and the lower part would not. So there's a lot of thoughts that had to go on to actually make this look the way it does. And yeah, that's for the greater body. The connecting rod, pretty simple, not really gonna open that. The cheese holder, now the cheese holder was something else to do. The cheese holder was something else, especially when I had to do the assembly. And the only reason is because, the other two parts I showed that were the hardest had two planes, right? So like I had to model in the top plane, and I had to model in the bottom plane. I had to model this in about three different planes. It was something else. It was something else. Oh my God. Um, I had to do this because this was more or less like hollow, but only to this plane, right? It's not hollow from somewhere here. It's pretty much just hollow from here to here. I had to do these patterns because the teeth to basically signify the teeth of the cheese holder. I had to do a hollow or like a shell command or feature for this for the inside. But then I also had to do some kind of like extrusion because what happened when I did a shell is that it basically made a shell everywhere, right? So I pretty much had to break them and tell SolidWorks, okay, these are two different bodies, and I wanted to hollow just one body. So it was extremely crazy. And then the last, and yeah, I mean that's pretty much it. Just gonna show you guys the assembly now after putting everything together. How did it look? Showing you guys now. And okay, so let me just expand my mates, see if I can remember a couple of them. Okay, there are a lot of concentrics. I find the concentric command really good in SolidWorks. I started learning 3D modeling with Onshape. I find the revolve, is it revolve command or I'm not sure what Onshape calls it. I can't remember anymore. I think like a circular command or something like that for the assembly mates to basically show that these two are concentric. No, yeah, it's a revolve mate. I'm sure it's a revolve mate. But why I like this one is that you're not telling SolidWorks you want them to move together. Yeah, just telling SolidWorks that like no matter how you move any of them, the other one should follow through. I really don't know how best to explain it. I think if you use the on-chip assembly and you've used SolidWorks assembly, you understand exactly what I mean. So the concentric was great with this. The width assembly made I find that extremely wonderful. Uh, Basically to tell SolidWorks that I want a part to be at the very middle of two faces. It's extremely good. I use that a lot. I had to use it in a couple of places as well. Um, and then concentric, I use, if you look to the list, you see concentric covers like 80% of my mates. Okay, and then the coincident, the gem mates, or the gear mates, sorry, I really like this. I really like this mate in SolidWorks. It's basically to tell SolidWorks that you want two things that touch to be connected such that revolving one of them revolves the other one. Now there are different settings for if it was an actual gear, like if one is bigger than the other, and one is like times two of the other, and like the revolution of one in like a point one rad makes a point two rad revolution in the second one. You understand what I mean? Or like angular displacement, however you like to call it. But for this one, it's pretty much a one to one. I don't want anything fancy like that. I just want them to move together. You could also, if you check the edit, you could also edit like the direction, so you could reverse it as well. Which of course, like I said, I really wasn't interested in doing all of that. Something that took me a lot of time to do is the tangent. Oh no, not this one. Yeah, it's pretty much for this. Pretty much for this. Because I one thing I really don't like with SolidWorks, I can't remember if Onshape also had the same thing, but SolidWorks doesn't help in like motion detection. Yeah, motion detection. That's what we call it, right? So if I went here, for instance, in move component, collision detection, I'm so sorry. So stop at collision. You could actually tell SolidWorks, oh, I want to move a particular component and I don't want them to touch and all of that. But the annoying thing is it doesn't do that except you are in that space, which I really didn't like. So you pretty much have to I use limits to limit the movement because of course if you submitted it to an instructor and your grader was literally your trace holder was going into this, of course that wouldn't make sense. Let me show you guys what I mean actually. See, right? So I don't think OnChip did this. If he did, I probably don't remember. But OnChip, I think that's one thing I really didn't like in SolidWorks. So it doesn't make sense, of course, right? It really doesn't make sense. So I just have to use a limit angle to 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 show that, oh, okay, this shield holder. I had to limit it to, although that's something else I like with SolidWorks that I just realized actually. I just learned it pretty recently that you could use a limit angle in certain planes. So in cases where, for instance, I would have wanted to use a limit angle on this grater because that's what it's actually touching. But the grater is a circular body, so I didn't know at that time how best to do that. But now I would just use still a limit angle, but just make use of the planes because all the planes are actually still here. So the top plane, for instance, the front plane, the right plane, like I really could have made use of all that instead of making use of this line. But like I said, I just didn't know it at the time. And yeah, I mean it's still pretty much it's still similar to what I said earlier of how you basically keep on learning and then that's what you have to do. Keep on learning, keep on seeing new ways or different ways of trying different things. So eventually, this how it moves like this, right? Because of course the handle had to move this way, and then there are a lot of things going on here. Um, and I could try to open the exploded version as well, so that you guys can see that a little bit better. But then if I move to this side view actually, so that you see it properly, and then you see that, and then you see that it's not just moving, right? It's actually causing the grater to move, which it should. So that's pretty much it for this project. It was a really good project. I really enjoyed it. Let me try to open the exploded version as well. Yes, so I really enjoyed it. I really found it useful. Okay, this is what I'm talking about. So these three prongs, the prongs had to go in through here, through the holes. So it also had to be concentric as well and all of that. You see this? It had to go in through the dowel hole. The base had to cover this. This bus base had to go into this hole. So all of that was just something else really. But like I said, eventually it's a really nice project. I don't regret the amount of time I spent on this actually. Thank you so much guys for watching. And I'm gonna be trying to post a couple of the skills I've learned while learning SolidWorks. And just watch out for any more videos in the future if you see them on your page or if you come across them, let me know what you think of them as always.